For millennia, humans have gazed up at the stars and wondered, are we alone? It's a question that speaks to our deepest curiosities about our place in the cosmos. Today, we're closer than ever to answering that question, not by searching for little green men, but by hunting for something far more subtle. Biosignatures. Biosignatures are the telltale signs that life, whether past or present, might exist or has existed on other planets and moons. These signatures can be chemical, geological, or even technological in nature. Finding them is like piecing together a cosmic puzzle, where each clue brings us closer to understanding if we're truly alone in the vast expanse of space. Join me as we delve into the fascinating world of biosignatures and explore the cutting-edge science that's pushing the boundaries of our knowledge and bringing us closer than ever to answering one of humanity's most profound questions. Are we alone? So, what exactly are we looking for when we hunt for biosignatures? Imagine you're a detective arriving at a crime scene. You're not looking for the perpetrator themselves, but for the evidence they've left behind. Fingerprints, footprints, maybe even a dropped wallet. Biosignatures are like those pieces of evidence, but instead of a crime, they point to the existence of life. They're the fingerprints that life leaves on the environment, subtle hints that tell us something remarkable might be happening on a distant world. Let's start with chemical biosignatures. These are molecules or combinations of molecules that are produced by living organisms or are essential for life as we know it. One classic example is oxygen. Here on Earth, we have an abundance of oxygen in our atmosphere thanks to billions of years of photosynthesis by plants and algae. If we detect a significant amount of oxygen in another planet's atmosphere, it could hint at something actively producing oxygen, possibly even life. Then there are isotopic biosignatures. Isotopes are variations of the same element with different numbers of neutrons. Living organisms tend to prefer certain isotopes over others. For example, life on Earth prefers the lighter carbon-12 isotope over the heavier carbon-13. An unusual ratio of these isotopes in a Martian rock sample could suggest life played a role in its formation. Moving on, we have mineral and geological biosignatures. These are large-scale features or patterns created by the interaction of life with its environment. Think about coral reefs here on Earth. These massive structures are built by tiny coral polyps over thousands of years and are a clear example of how life can leave a lasting mark on the planet's geology. Similarly, the presence of certain minerals like those formed by the interaction of water and life could be a significant clue in our search for biosignatures. Finally, we get to the really exciting stuff, technosignatures. These are signs of advanced technology that could indicate the presence of intelligent extraterrestrial civilizations. While still in the realm of speculation, technosignatures could include things like radio signals, megastructures like Dyson spheres, or even evidence of interstellar travel. Now that we know what biosignatures to look for, the next question is, where do we look? Our solar system alone is teeming with potential hotspots in the hunt for life beyond Earth. Let's start with our next-door neighbor Mars. Mars has long captivated our imaginations as a potential abode for life. Evidence suggests that Mars was once a much warmer and wetter planet than it is today, with rivers, lakes, and possibly even oceans. While its surface is now a dry, desolate desert, there's still a chance that microbial life might exist beneath the Martian soil, shielded from the harsh radiation that bombards the planet's surface. Moving further out, we encounter the icy moons of Jupiter and Saturn, particularly Europa and Enceladus. These moons might seem like unlikely candidates for life, as their surfaces are covered in thick layers of ice. However, beneath those icy shells lie vast, global oceans of liquid water kept warm by the gravitational pull of their giant host planets. These subsurface oceans are thought to contain more water than all the oceans on Earth combined, and where there's water, there's always a possibility of life as we know it. In fact, scientists believe that the conditions in these oceans might be similar to those found in hydrothermal vents on Earth's sea floor, which are teeming with unique and resilient life forms. But our search for biosignatures doesn't stop within our solar system. Thanks to powerful telescopes like Kepler and TESS, we've discovered thousands of exoplanets, planets that orbit other stars. Some of these exoplanets are located within their star's habitable zone, the region around a star where temperatures are just right for liquid water to exist on the planet's surface. These Goldilocks planets are prime candidates in our search for life beyond Earth. By studying the atmospheres of these exoplanets as they pass in front of their host stars, we can look for the telltale chemical fingerprints of life. And then there's Venus, our other planetary neighbor. Venus is often called Earth's evil twin due to its scorching surface temperatures and toxic atmosphere. It's certainly not a place you'd want to spend your summer vacation, but recent studies have suggested the possibility of life existing in Venus's upper atmosphere where temperatures are cooler and pressures are more Earth-like. Chapter 3. How do we detect biosignatures? Detecting biosignatures on other worlds, whether they're faint whispers from Mars or subtle signals from a distant exoplanet, requires some seriously impressive technology. It's like trying to hear a pin drop in a hurricane from miles away. Fortunately, scientists have developed some incredible tools for the job. One of the most powerful tools in our biosignature hunting arsenal is spectroscopy. Now, this technique relies on the fact that different molecules absorb and emit light at specific wavelengths. It's like each molecule has its own unique fingerprint in the way it interacts with light. By analyzing the light coming from a planet's atmosphere or reflected from its surface, we can identify the presence of specific molecules, even in tiny amounts. Remember the oxygen we talked about earlier? Spectroscopy can help us detect that, along with other potential biosignatures like methane, ozone, and even more complex organic molecules. Of course, to get a closer look, we need to send emissaries to these distant worlds. That's where space probes and rovers come in. These intrepid explorers are our eyes and ears on other planets, equipped with instruments to analyze soil samples, study the atmosphere, and even search for signs of ancient life. Take the Mars rovers, for example. These robotic geologists have been tirelessly exploring the Martian surface for years, sending back invaluable data and stunning images. They've drilled into rocks, scooped up soil samples, and even taken selfies, all in the name of science. And let's not forget about the telescopes. These giants of ground-based and space-based astronomy allow us to peer into the distant corners of the universe and study the atmospheres of exoplanets light-years away. The James Webb Space Telescope, launched just a few years ago, is a game-changer in this regard. With its unprecedented sensitivity and resolution, the James Webb Telescope is capable of detecting the faintest signals from distant worlds, potentially revealing the presence of biosignatures in the atmospheres of exoplanets. And then there are radio telescopes, which we use to listen for signals from potential extraterrestrial civilizations. While we haven't picked up any alien messages yet, at least none that we've been able to decipher, the search continues. After all, if another civilization out there is technologically advanced, they might be sending out signals just like we are. Chapter 4. What would a confirmed biosignature mean? Imagine the headlines. Scientists discover evidence of life beyond Earth. The confirmation of a biosignature on another planet or moon would be one of the most profound discoveries in human history, fundamentally changing our understanding of life in the universe. But finding a potential biosignature is just the first step. Before we start popping champagne bottles and planning our first interstellar vacation, we need to be absolutely sure that what we're seeing is truly a sign of life and not some weird geological quirk or an unknown chemical process. Scientists are inherently skeptical bunch, and for good reason. Extraordinary claims require extraordinary evidence. So if we were to find a potential biosignature, say, a plume of methane erupting from the icy surface of Europa, the scientific community would go into overdrive trying to confirm it. First, they would meticulously analyze the data, ruling out any possible errors or instrument malfunctions. Then, they would look for alternative explanations, trying to determine if the methane could be produced by a non-biological process. They might even design new experiments and missions to gather more data and test their hypotheses. The process of confirming a biosignature could take years, even decades, of painstaking research and analysis. But the implications of finding life beyond Earth would be so profound that it would be worth every ounce of effort. It would mean that we are not alone in the universe, that life is not a fluke confined to our little blue planet. It would open up the possibility of a universe teeming with life, perhaps even intelligent life, waiting to be discovered. It would force us to reconsider our place in the grand scheme of things, and ask even bigger questions about the origin, evolution, and nature of life itself. The discovery of a biosignature would be more than just a scientific breakthrough. It would be a cultural and philosophical game-changer, sparking our imaginations and inspiring future generations to explore the cosmos with a renewed sense of wonder and purpose. Outro, the future of biosignature discovery. With cutting-edge telescopes and upcoming space missions, we may soon find the first undeniable signs of alien life. Whether it's microbes beneath Martian soil or complex life on a distant exoplanet, the discovery of biosignatures could reshape our understanding of the universe forever. We're on the cusp of a new era of exploration, an era where the search for life beyond Earth is no longer science fiction but a tangible reality. The tools and techniques we've developed are more powerful than ever before, and the possibilities for discovery are truly limitless. What do you think? Will we find signs of extraterrestrial life in the next few decades?